In this PPT, we going to see the what is a trees and difference between the binary tree and the binary search trees, and its advantages and disadvantages, also the applications. Finally, implementations of the trees by the program, what is happening in that program and how the tree can be implementation, that also see in this PPT. What is trees means? A tree is another logical data structure. Tree is a non-linear and hierarchical data structure. Tree has a root node and the parent and the child node. For example, this is root node, and this root node was also the work as a parent node, and these are the two children that root node have. And this from this diagram, these two are the parents for these childs. So this is the tree. This is implemented by one value is taken as a root, and this is 10. The root is 10 means lesser than values are splitted into this left or the lesser sides and right or the greater value sides. 7 is placed is here and 11 is placed in here, like that. The numbers and the values are placed in the trees. And the reason for using trees is a lot of situations are stored in the hierarchical manner. Suppose I take a file system, means in the computer it has a file systems of a simple nodes, which is this is file system. It containing the home page. Containing the home page, and these home has the courses, and these courses have the three directories of CS101, CS112 and CSS113, like the directories have. And this has is the also another home, like that. These file system has the two directories. These course has the three directories, like the directories are displayed here. By this directories, this home has a hierarchical data structure. So we are using the trees to implemented what is happening in the directories, and the home is also in the file directories. By the trees is easy to implemented, so we are using the trees. Advantages of the trees is stored list of values in the linear data structure. Accessing and searching is quick than the linked list. From the linked list, searching is to be from the head node traverses one by one, then the searching is completed. But in the array it is very easy to by the index only it catches by the values, but in the trees it is lesser than the array and greater than the linked list, like that it is comparable. And disadvantages of the trees is, in trees insert node and number of nodes searched is less only. Searching is lesser than the array, so already tell that now. Then applications of trees is manipulations hierarchical data and easy to search, or sorting is easy. Router algorithms in file systems, router algorithms is there. From this router algorithms is implementing in the trees data structure is very easy. From the next part, this is the binary tree and this is the binary search tree. Difference between these two is, binary search tree has only the two childrens. Each parent has the two childrens only occupied. By the binary trees, occupies extra childrens is also placed here. This parent has two child, this parent is also two, this is also two. From this only one is happens, this is not null is happens, or it has the child of 3 is also included in the binary tree is possibles only. So binary tree has the extra nodes. Parents has two childrens in occupies only the binary search tree, but in the binary tree more than that two children, two child, three children or four children are possible in the binary tree. binary tree. This is the difference between the binary and the binary search trees. Next, implementations of the binary tree by this program. This is the new node. This new node is getting a root only, passing the root, it getting the roots values, and before the value inserted, left and right, it should be the null. It is a malloc of size occupied by the nodes, and this is return node. How this return nodes, this is all the structure functions of the allegation new nodes, and this is the main function in this root node, passing a values, creating the node values. Root is equal to 1 and left is equal to 2 and right equal to 3. That's all, keeping inserting the node values in the main functions only. After that, this is the main structure program of the trees, data structure program. This is very simple. No, int data means it is a root node inserting, and left and right means it is a left and right nodes inserted in the structure node. And by this programs, we want to calculate the post order, pre order, and in order. I included this three simply by the post order. Post order means root is in the last, left, right, then root. That is the post order. Pre order means root is firstly come, root, then left, then right. This is the pre-order. Then in order means root is inner part to be occupied. So left, root, then right. So this way of formulas by only occupying the values in the trees. For example, from the program of the post order and the pre-order and the in order, we want to calculate the values. Okay, that is easy to find the how it will come. From the first one, post order. No, in this program, post order, this is the root node passing, and the and this is when the node is to be null and the reach that value and return when the reach the null position, the node is to be returned in that value in this the given position. And the first one, post order, node to be left. Post order is means root is to be posted. First one is left, right, and then the root. So first one is left. For this program, 1 is 2, this is 3, and this is 4. From this tree only occupying by this new nodes. So this tree, from checking the left only, 2, next it's 4, next to be it is null position. When it reach the null, it returns the values here. When it reaches the null, it goes and comes here. This is the recursion function only, it calling itself. Where it is calling before, that's before places only it returning the values. Only these left is to be called. No, so returned here only left values of 4, and then first writing 4, then checking right side. From the right side, from the it is calling before functions, to going to the 4 and to the 2, and to the 4 it's calling. Then the checking of the right side, it is null position, this is also null position, and going to the null is to be reached and returns the value of 2. Then it calculated to be the node, and also it's getting the right side position. It is a 3 is here, so placed 3, and then it checking the right, this is null, so it returning the values. And after going to that same place of this one node, one is here, and returning that node. So this is how the post order is happening. And then the in order means, I already told that in order is root is inside occupying the values, and after before left and after the right. So root is inside, no, it is happening in the formulas of left, root, then right. So in ordered, this is the root node passing values, and the first one is left, no. So checking the left values here, and after reaching the null point, it returned the value of the 4, and again goes to that before calling places, and it's checking the right is null, so again calling the left, and it is 2 here, and again calling the null, it reaches the null, so it returns the value of 2, and is again going 1, it is again going 1. After the left completions, root only there, so 1 is to be placed here, then it goes to the right point, 3 is there, it's not after checking the null position only 3 is to be written here. So this is how working in the in order. Next one is pre-order. In order is here to be the same left, root node and right, data is replaced by the root is here, and then pre-order is placed here. Pre-order's formula is pre-order means root is occupied the first position, so root, left, then right. This is the formula for the pre-order. This is passing the node values, and after that first one is data. The data means a root, it's checking the root values, it means the given data is 1 2, this place is 4 and this place is 3, so it is checking the first root position. So root is here, so returning the roots. Return roots means that is called as a print read. So it not reaching the null, root is always has the child nodes, it not reach the null position, so it returns by the printf statements. Then only it goes to the left position, then it again checking the left position, then it again checking the left position, it reaches the null, it returns the values, and again calling the same position of 4, and again calling the before calling functions of 2, it placed here, then calling the right position is null here, to reaches the null, it returns the value of null. After that null, it checking totally the left position is finished, and after it checking the third one, and third one is placed here. So this because this null is all, this right is also be null, so the 3 is to be returned, or else this part is first 2 checking left, node is righted here, no, first one is node is righted, then it checking the second one and fourth one. After that reaching the null position, it going to be that same one, and there it is come from the 2 only come from the number of reaching the null, so it places the 2 position, then it checking the right values, it is also the null, and going to be the same calling functions of 1, it already written, so it going to be the functions of 2. After that it reaching the right position, left is also null, right is also null, and the 3 is to be printed. So 2 is to be after reaching the null only it get it, no, so 4 2, instead of that 2 4 is also correct in this node.